you can take the same data and store it in different file formats, and that will allow you to have more or less functionality in terms of what you can do with that data. So that's where I think the rubber really hits the road, or it applies to us in terms of GIS users, is depending on whether something is in a coverage, a shapefile, a geodatabase, or some other file format, that will have very big implications as to what we're able to do with that data in terms of things like efficiency and error detection and so on. And if we're getting data from somebody else, then we'll know that those options were or were not present. So my little analogy here is, imagine if you just had, this is the syllabus from one of my courses, in a Microsoft Word format. Okay, and so if you think of the words in this document as the data, then the fact that it's in a Microsoft Word format, this is a docx file, that's a data file structure, or a data model, if you want to think of it that way. And so what that means is that we've stored those words in there, but because it's in that data file structure format, is that it allows us to do other things with it. So in that file are stored things like the fact that there's an image in that file, or that there's bold styles, or italics, or tables, or certain margins, that kind of thing. If we took those same words, the same data in other words, and stored them in a different file format, in this case a text file, then you'll see that we have all the same content that we did in terms of the words of that syllabus, but we don't have any of the other functionality. So we've lost all of the style settings, all the things about images and word wrapping and bold and italic. So those are elements of functionality that have been lost because we chose a different file format. So one is sort of a richer, more highly functional format. One is a less functional format. So why would you pick one versus the other? Well, it depends. If you're really into making sure that everything looks really nice and you have those functions available, you might use a Microsoft Word format. But what if you're sharing that data with somebody that doesn't have Microsoft Word, or you're not sure if they will, or maybe they're going to use some other software? Well, a text file is a much simpler data format that allows you to make sure that almost anyone will be able to read this with just about any kind of software, but you've lost that functionality. So this to me is a very direct analogy to the choices that you make in terms of GIS file formats. Is some of them have, they all will store the same data, by the way, so you'll be able to store your points, lines, or polygons, but beyond that, in terms of things like topology, you'll have more or less functionality depending on which file format you use. So let's have a look at the three main file formats, which are also kind of data structures or data models that Esri uses for their software. So I'm going to do these in chronological order. In the early days of GIS, we had ArcInfo as the main or only software that Esri produced at that time, and that was in the 1980s. Then in the 1990s, they created this software called ArcView, and then in the 2000s, they created ArcGIS, which is basically what we're using today. So these have overlapped in time. It's not to say that when ArcView came out that ArcInfo was immediately dropped. That's not the case. And the same thing between ArcView and ArcGIS, or even ArcInfo and ArcGIS. They overlapped quite a bit in time, but this is when each one of them was introduced, and this had a big effect on the file formats that were created. So the file formats related to these are the coverage, which was created for ArcInfo, the shapefile, which was created for ArcView software, and the geodatabase, which was created for ArcGIS. Now, the same data can be stored in any of these file formats, and essentially it will look the same to begin with anyway when you bring it into whatever software you're using. So you can store the same data, just like we can store the same words in a Word document versus a text file. We can store the same polygons in a coverage, a shapefile, or a geodatabase. So in the early days of GIS, there was a big emphasis on data quality and on error detection and prevention. So at that time, topology was a must. You had to include topology. It was the only way that you could really create this data was to digitize something and then build topology for it. And so this was a fairly complicated file format to work with, but the advantages were, especially if you think back to the 1980s, the early days of computers, file storage was expensive. There wasn't much of it available. We're talking about file storage in the megabytes instead of, gigabytes or terabytes. I remember those days. And so, and computer processing power, which was much less than it is today. And so they had to be as efficient as possible in terms of how things were processed. So they enforced the idea that you had to use topology, but because they did that, creating data was fairly time consuming and tedious, and working with it was a bit complicated. So it was a bit hard to use, but the data was efficient. Then in the 1990s, they created this software called ArcView. And the whole idea then, this is sort of a quick history, was that they wanted to create software that was much more user-friendly for a much wider audience. And then they wanted to create a file format that would go along with that. So the idea there was that, well, then we won't have topology at all in the shapefile. It's not even possible to have topology. So if you want to have things that don't line up correctly, or you want to be able to do something that's sort of quick and dirty if you want, go for it. You can do that with a shapefile. So there was no topology. It was very simple to use. In fact, it was referred to as a simple data model. So it was easy to use, but it was inefficient because you had to store things more than once. There was no easy way to detect when things didn't work correctly topologically. And because of those things, the processing in terms of spatial analysis was not as efficient. Now, computers were becoming faster, storage was becoming cheaper, so it was less of a problem, but it was still an issue. So they went sort of from, in my mind, from one extreme to the other, from the coverage, meaning you had to have topology, to a shapefile where it wasn't even possible to have topology. You could still use a coverage, so you had the option of using one or the other. And then in the 2000s, along came this new software called ArcGIS. It was written from the ground up. It was a brand new piece of software. I remember when it came out, it was a big deal. And again, they wanted to create a new file format that was custom made for this new version of the software, and that was the geodatabase. And so one of the big advantages of this was that topology was optional. You could include it or not include it. You could create data and decide later that, oh, maybe we do want topology for this data set, and you could do it whenever it was useful for you to do that or not. So it was much more sophisticated in terms of what the geodatabase could do and what it could store. It was much easier to use, and there was a big increase in functionality in terms of the options you had available for topology and other things. So that's just kind of a quick overview. I think that anyone working in GIS today, even if you don't use Esri software, it's useful to know about this because Esri is so influential in the GIS world, and the file formats that they use are very common. So for example, the shapefile even today is still like a de facto standard because it's so straightforward and easy to use. It's often used for file sharing, data sharing. And the geodatabase is one that's become more popular now because of some obvious advantages to it. As a way of illustrating what the geodatabase is capable of in terms of topology, these are the rules that are available for topology. So in the early days with the coverage in ArcInfo, there was 3 different topological rules that were possible. Now we have a whole bunch of them here. And so here's some examples of them, is that we have things like a point must be inside a polygon. So this might be a thing like where you have the state capital, and you want to make sure that that point that represents that capital is inside the state itself. You might have lines that have to be on top of each other, and these could be in different feature classes, by the way, not just inside one map layer. So it could be that you have bus routes that you want to make sure are exactly on top of roads, so that if the if you have roads and you have a bus on that road, you don't have a bus going through a park or something like that. What's really cool about the geodatabase, though, too, is that you can set up a rule so that if that road line moves, if it's edited in some way, you can set it up so that that bus route is also moved at the same time automatically. That's a huge advantage over these earlier data models. And you could have classic topology rules like must not overlap as well. So these are just some examples. I want you to just be able to kind of visualize what we mean when we're talking about topology. Because I don't know about you, but sometimes when we're talking about data models and file formats, it may not sound like the most exciting thing. So I really try to emphasize the practicality of it and how useful it is for you as a GIS user.